In this video, we're going to look at different quadrilaterals, and this is going to be split into at least 2, maybe 3 recordings. So in this section, 8.1, we will identify specific quadrilaterals based on characteristics. Generically, a quadrilateral is simply any 4-sided polygon. And we're going to start with our parallelograms. In a parallelogram, your opposite sides are congruent, so I'm going to use the congruency marks. So AD is congruent to BC, and AB is congruent to DC. I'm using 2 different tick marks because they may or may not be the same length. Also, opposite sides are parallel. So that means side AD is parallel to side BC, and side AB is parallel to side DC. And again, we're using the parallel symbols that you were introduced to earlier in the school year. Okay, so that's the sides. When we talk about opposite angles are those that are across from each other, and opposite angles are congruent. So in this case, angle A is congruent to angle C, and angle D is congruent to angle B. Along with their opposite angles being congruent, consecutive angles are simply the angles that are side by side as you go along the parallelogram. So A and B are consecutive angles, B and C are consecutive angles, C and D are consecutive angles, as well as D and A. Notice we're going along the outside of the parallelogram and not across. If you have consecutive angles, then they are supplementary. So, angle A and angle B are supplementary. Now, because C is opposite of angle A, I'm going to use the same highlighter. And so we have the measures of angle A plus the measure of angle B is 180, because that is what supplementary means. And the measure of C plus the measure of B is 180. And we can continue going around the parallelogram. Measure of angle C plus the measure of angle D is 180. So those are the characteristics of parallelograms. Opposite sides, congruent and parallel. Opposite angles, congruent. Consecutive angles are supplementary. So now we're going to move down to rectangles. Rectangles are a subgroup of parallelograms in that, just like parallelograms, your opposite sides are congruent and parallel. Your opposite angles are congruent. However, in a rectangle, they are all right angles. And just like your parallelograms, your consecutive angles are supplementary. They're all 90 degrees. Measure of angle A plus the measure of angle B is 180. The measure of angle C, etc. Okay? So again, rectangles, subgroup of parallelograms. The only difference is that you now have all right angles. The next subgroup we're going to look at is squares. Squares are parallelograms. They're also rectangles in that the opposite sides are congruent and parallel, but the difference between rectangles and squares is that all of the sides are congruent and opposite sides are parallel. Okay, so we're getting down to smaller subgroup. Just like the rectangle, your opposite angles are congruent, and in fact, are right angles. And just like your parallelograms and your rectangles, consecutive angles are supplementary. Okay. Going on to our next quadrilateral, we're going to look at a rhombus, plural rhombi. Again, subgroup of a parallelogram. In a rhombus, all sides are congruent. So very similar to your square, opposite sides are parallel. But the difference between a rhombus and a square is that your opposite angles are congruent. They are not right angles. And continuing on with consecutive angles, your consecutive angles are supplementary. And again, consecutive angles are simply those that as you go around the quadrilateral, they follow each other. Okay. Now we're going to move to trapezoids. Trapezoids are quadrilaterals in that they have 4 sides, but they are not a subset of parallelograms. Okay? For your trapezoids, opposite sides are called bases. Okay? So in this diagram down here, AC and BD are opposite sides, and AB and CD are opposite sides. But notice we have one pair of parallel sides. As we look at our diagram here, AC is parallel to side BD. And it is the parallel sides that are the bases. So in this case, AC and BD are your bases, and AB and CD, you can refer to them as the legs. Okay. Now, consecutive non-base angles. Okay, these are the angles at the end of the legs. Okay, so in this case, it would be angle A and B and angle C and D. Okay, these are your consecutive non-base angles. When we look at the consecutive non-base angles, they add up to 180, so they are supplementary, and all 4 angles add up to 360. Okay? So let's work this example here. We're told that the measure of angle A is 100 degrees, and the measure of angle D is 75 degrees. And we want to find the measure of angle B and the measure of angle C. Well, according to this, because A and B are consecutive non-base angles, the measure of angle A plus the measure of angle B equals 180. I'm going to substitute in 100 degrees for the measure of angle A. And notice when I solve for the measure of angle B, I'm going to subtract 100 from both sides. And we get the measure of angle B is 80 degrees. Now to find C, C and D are consecutive non-base angles, so they add up also to 180 degrees. I substitute in 75 degrees for the measure of angle D, and I get the measure of angle C equals 105 degrees. All right. Staying with isosceles, we're going to make one slight change, and notice that we've got the legs marked congruent. So we have one pair of parallel sides, those are our bases, and one pair of congruent sides, I refer to those as the legs. Okay? So we still have the consecutive non-base angles adding up to 180, being supplementary, but we have another condition that is met. These are what I would call consecutive base angles. In other words, they're side by side, but they're at the end of the bases. If you have an isosceles trapezoid, then your consecutive base angles are congruent to each other. So that's a new condition that has been introduced for isosceles trapezoid. Okay? So let's look at this diagram here. We have an isosceles trapezoid. I know this because the legs are congruent. So if I know Q is 110 degrees, I know R because R is a consecutive base angle. So R is going to equal 110 degrees, as the same as Q. Now, when I want to find angle S, notice that angle R and angle S are consecutive non-base angles. Consecutive non-base angles are supplementary. So that means I have the measure of angle R plus the measure of angle S equals 180. The old part plus part equals whole. R is 110 degrees, so the measure of angle S will be 180 minus 110 degrees, which gives us 70 degrees. When we want to solve for x, notice the two congruent sides. If they are congruent, their measures are the same, so I can set them equal to each other. 3x equals 12. Divide both sides by 3, and we get x equals 4. The last quadrilateral we're going to look at is the kite. So what I need you to do is cross out rhombi and put the word kite. And it has several conditions. In a kite, two pairs of congruent consecutive sides. Okay? So here is a pair of consecutive congruent sides, and here is the other side. Okay? So the way this is marked, side BC is congruent to BA, side DC is congruent to side DA, and because they are congruent, their measures are equal. All right? Now, If we draw a diagonal is simply a line segment drawn from one vertex to a non-consecutive vertex. Okay, so it's drawn from angle B to angle D. That's one diagonal. And the other diagonal is from angle C to angle A. And what you find with a kite, your diagonals are perpendicular, hence the box here. So what we have created is 4 right angles, BEC, DEC, BEA, and DEA. They are all right angles. That means they measure 90 degrees and they are all congruent. Okay. Now here we have to be careful when we talk about opposite angles. Okay? Opposite angles are the angles formed by the two non-congruent sides, the two consecutive non-congruent sides. So this is an opposite angle, and this is an opposite angle. So it's not enough to just say they're across from each other, because B and D are across from each other, but they are not opposite and they are not congruent. Okay? So why are they congruent? Well, as you recall, we have perpendicular diagonals that form right triangles. Okay? So this angle here is congruent to this angle here. Measure of angle BCE is congruent to angle BAE. Okay? Then if we move over to this angle, ECD, mark that way, is congruent to angle EAD. And I'm using colors because this is a small diagram and it's hard to get a lot of arches in there. Which means if these two angles are congruent and these two angles are congruent, the sum of the two angles are congruent. Therefore, you have congruent opposite angles. Okay? So that's the opposite angles. There's also a special relationship with the two other angles. This diagonal that connects the two angles that are formed by consecutive congruent sides actually bisects it. Okay? Diagonal AC is bisected by diagonal BD. So since this diagonal is bisected by this diagonal, that tells us that EC is congruent to EA. And because they're congruent, we know their lengths are the same. Because BD bisects angle B and angle D, or angle CBA and CDA, bisecting means the measures of angle CDE equals the measures of angle ADE. And the same thing on this side. It bisects angle CBA, so that means angle CBA has the same measures angle CBE has the same measures as angle ABE. So a lot of things with kites. So let's walk through this example. All right, we're told that AC is 10 units long. ED is 12 units long, and EC is 5 units long. Well, if you look up here, this shorter diagonal is bisected. So if AC is 10 and that's 5, this is also 5. Okay? So let's look at solving for CD. CD is the hypotenuse of triangle CED. And to find the hypotenuse, we're going to use Pythagorean theorem. So if we want to find the length of CD, it's going to be the square root of the sum of the squares of the sides. So it's going to be the square root of 5 squared plus 12 squared, which gives us the square root of 169, which gives us 13. So if we know the length of CD, notice it's congruent to side AD. So if CD is 13, AD is 13. We want to find the measure of angle AED. Our diagonals are perpendicular. Perpendicular lines form right angles. So that means angle AED is a right angle, and all right angles measure 90 degrees. Okay? Now, we want to find the measure of angle ADE. We're going to have to use trig for this. Okay? If we want to find the measure of angle ADE, notice we are given the two legs. The trig ratio that involves the two legs is tangent. So the tangent of angle ADE equals 5 opposite over adjacent 12. So that means if we want to find the measure of angle ADE, we take the inverse of 5 divided by 12. And when we plug that in the calculator, we get 22.6, which if we're rounding to the nearest degree, is 23 degrees. We want to find the measure of angle CDE, which because BD bisects angle CDA, it's going to be the same as angle ADE, so this is also 23 degrees. And if we know the two measures of the bisected angle, we're either going to add them together, 23 plus 23, or take one of the angles, 23 times 2, and we get 46 degrees.